Hello students, welcome to 10th lecture of chemical bonding and molecular structure. So in previous lecture we discussed about orbital overlapping concept, and now let's proceed further and we will get some details about overlapping with different type of orbital, that means with s, p, d and f orbitals. When these type of orbitals overlaps, which type of bonds will be produced? So let us discuss the topic in detail. Directional properties of bonds. So as we already seen, the formation of covalent bond depends on the overlapping of atomic orbitals, and as mentioned in previous point, orbitals are not rigid, okay, they are not like solid spheres, but they are like clouds. That means we can assume them as a cloud of gases. That means we can mix two different clouds with each other without any problem. If you want to mix or overlap solid surfaces or solid matters, then it is hard to mix with each other. But gaseous states are easy to mix with each other, and actually electronic orbitals are not solid or rigid shapes. So they can overlap depending on the attraction. But overlapping also has limit because of repulsion. When we place two similar charged particles close to each other, they will repel each other, and as we decrease the distance between two atoms, attraction as well as repulsion also increases. So we have to find a balance point when attraction will be maximum and repulsion will be minimum, so that molecule can stabilize, and we call it bond. So the molecule of hydrogen is formed due to the overlap of one s orbital of two hydrogens when they combine with each other. Okay. In case of polyatomic molecule like methane, ammonia or water, the geometry of molecule is also important in the addition to the bond formation. Now geometry is already discussed in previous point. When we have two different atoms, it will be linear. In three different atoms, it will be either linear or angular like water molecule. For 3 it will be planar triangular. For 4 it will be either triangular pyramidal or tetrahedral, and so on. Okay, so we already discussed about the different type of geometries. For example, methane molecule and ammonia molecule, both of them contains same type of hybridization, that means carbon and nitrogen, both of them uses 1s and 3p orbitals, and both of them contains total 4 electron pairs around them. But in CH4 we have tetrahedral molecule and 109.5 degree angle, and NH3 is pyramidal. Okay, so valence bond theory explains the formation of directional properties of bonds in polyatomic molecules like methane, ammonia, water, etc. in terms of overlap and hybridized atomic orbitals. So now let us discuss about the overlapping of atomic orbitals. We already know that we have some different types of orbitals in atom like s, p, d and f. So, and all of them has different type of shapes. That means s is a spherical orbital, just like a solid ball like shape. P is dumbbell shape, D is more like double dumbbell shape, and F orbitals have many different complex structures. So when two atoms come close to each other, there is overlapping of atomic orbital. This overlap may be positive, negative or zero depending upon the properties of overlapping. Now here positive, negative and zero overlapping does not indicate charges. They actually indicates probabilities. That means when two similar type of orbitals will overlap with each other, more details will be discussed in upcoming point. Okay, but keep in mind they are not representing the charge. Now the various arrangement of sp orbitals resulting in a positive, negative and zero overlap are depicted in figure 4.9. First, positive overlapping. So as we can see, we have two different pz orbitals of two different atoms, and both of them shows two different lobes. Okay, these are called lobes. If we talk about first, then this will be negative lobe and this will be positive lobe, and similarly for second, this is positive and this is negative lobes. And now both of them are pz orbitals, so that means they are present on Z axis. Now observe this, we have minus and plus both mentioned in PZ. So what this minus and plus represents? They represents probability of electron. Plus represents there is more probability to find electron in that lobe, and minus represents there is very less or zero probability of finding electron in that lobe. So that means, suppose if we assume in this atom pz orbital contains one electron, so this electron most probably will be somewhere here in this lobe. Okay, so probability of finding electron will be high in this positive side and it will be low or zero in this negative side. So actually plus sign represents more probability of finding electron of in that region. Okay, so it indicates if electron is present here and here. Okay, that means in first orbital as well as in second orbital electron is somewhere here. So that means both of these sides of two different orbital contains electron, and if both of them contain electron, then electron will be paired and bond will be formed. So if bond will be formed, then it will be positive overlapping. So it do not, again I am repeating, these plus and minus signs do not represent charges, they represent probability. Now as we can see in this case, we have plus and minus lobes for Z orbital, but S is spherical. That means we have only one region in S orbital, and probability of finding electron will be all over in this lobe. That means it will be equal in all of the region. That means in case of S orbital, it always contributes positive overlapping. So that means it depends on second orbital only. And when we have two px orbitals, they will be parallel to each other. Only one of the three p orbitals, px, py and pz, only one of these three will overlap like in a straight way as mentioned in this case. Remaining two will overlap this way. That means they will be parallel to each other. So these two parallel orbitals shows positive overlapping when positive and negative lobes are in contact with each other, and only in this case bond will be formed. Now let us concentrate on next, that means py. Again it will be parallel to each other, just like px, same type of possibility will be arises. Now let us talk about negative overlapping. When two different lobes combines with each other, that means positive of first and negative of second, it is called negative overlapping, and in this case of overlapping, bonds won't form. That means if two different atom approaches like this, they will be unable to form bond. That means probability of finding electron in this region will be comparatively high, but for second, probability of finding electron will be almost zero for this side of lobe, and you will find electron somewhere here. Okay, so that means first atom contains electron here, but second contains here. So electrons are comparatively away from each other, so bonds cannot be formed. And as discussed earlier, s orbital only provides positive lobes and it depends on second orbital. So in this orbital pz contributes negative lobe, that's why it is negative overlapping. Similarly, as we can see, if two parallel p orbitals are overlapping like this, again positive lobes is in contact with negative lobe and negative is in contact with positive, so no bond formation. And similarly p y can form these type of negative overlap as well. Then we have zero overlap when both type of possibilities are equal, that means positive overlapping as well as negative overlapping. So overall it will be cancel out and effect will be zero and no bond formation occurs. When we mix px and py with each other, now keep in mind both of them are in different axes, they are on different axes, so they are not touching each other, they are not in contact with each other. So there is no contact between px and py orbitals of two different atoms. That's why no overlapping occurs and it will be zero overlapping. The criterion of overlap as the main factor of formation of covalent bond applies uniformly to the homonuclear, heteronuclear, diatomic molecules and polyatomic molecules. That means you can apply this type of overlapping concept to homonuclear, that means molecules which contain same type of atoms. Heteronuclear, that means molecule containing different type of atoms. Diatomic, that means two atom containing molecules, and polyatomic, more than two atom containing molecules. In the case of polyatomic molecule like methane, ammonia, water, the valence bond theory has to account for their characteristic shapes as well. We know that the shape of CH4NH3 and H2O molecules are tetrahedral, pyramidal and pent respectively, as we discussed in previous theory. It would be therefore interesting to find out if these geometrical shapes can be explained in term of orbital overlaps. So depending on the position of different atomic orbitals, we can actually explain shape of molecule as well. Okay, if this theory is accurate, then it should be able to explain shape of molecule as well as bond formation. So let us first consider the CH4 molecule. The electronic configuration, we know that it is helium core 2s2 2p2. In the excited state, electron of 2s orbital will jump in p orbital. So now it will be 2s1 2p3. That means px contains 1, py contains 1 and pz contains 1 electron. The energy required for this excitation is compensated by the release of the energy due to the overlap between the orbitals of carbon and hydrogen. So what this point says, we have ground state configuration 2s2 2p2 for carbon, and in excited state electron present in 2s orbital will jump in 2p orbital. That means now we have only one electron in 2s and 3 electron in 2p. So as mentioned earlier, energy sequence will be n plus l. So n value for 2s orbital it is 2 and l value will be 0, s is equal to 0. So 2s is equal to 2 and 2p, n value is equal to 2 and l value for p is 1. So that means it will be 3. So obviously energy of 2s orbital will be less than energy of 2p orbital. So we are shifting electron from lower energy to higher energy orbital. So this transition requires energy. So where this energy will be obtained, from where it will be obtained? So it will be obtained when carbon forms bond with hydrogen. This reaction releases energy and released energy will be absorbed by the electron to do this transition. That means we have an exothermic reaction here which compensates the requirement of energy for this endothermic reaction. So 4 atomic orbitals of carbon, each with an unpaired electron, can overlap with 1s orbital of 4 hydrogen, which are also singly occupied. This will result in the formation of 4 CH bond. It will however be observed that while the 3p orbitals of carbon are at 90 degree to one another. Why they are 90 degree? Because as mentioned earlier, we have 3 different type of orbitals, px, py, pz, and all of them are present on x, y and z axis, and we know that x, y and z axis are perpendicular with each other. That means they contains 90 degree angle. So initially angle without bond formation with hydrogen, angles of p orbital will be 90 degree from each other. The HCH angle for these will be 90 degree as well. Okay, we are just talking about p orbitals without the influence of s orbital. That is 3 CH bond will be oriented at 90 degree to one another. The 2s orbital of carbon and the 1s orbital of hydrogen are spherically symmetrical. That means both of them contains ball-like shapes, and they can overlap in any direction. As mentioned in previous point, overlapping, positive, negative and zero overlapping. We have 3 different type of overlapping, and only positive overlapping allow bond formation. whereas negative overlapping actually opposes bond formation, and zero overlapping neither supports or nor oppose the bond formation. So s orbitals always forms positive overlapping. That means we can add s orbital overlapping in positive overlapping category. That means suppose this is one s orbital of first atom, and this is the s orbital of second. When they mix with each other, it results like this. Positive lobe of first will overlap positive lobe of second, and both of them are spherical and has probability of finding electron all over the sphere equally. So that means they always gives positive overlapping. So just for carbon, let us assume how initially orbitals will be arranged in carbon. Okay, so let us draw orbitals first. This is let us say x orbital, this is y orbital, and this will be z orbital. So s orbital is spherically symmetrical. That means it will be at the center of all of these three axes like this. Px will be like this, Py will be something like this, and Pz will be something like this. Okay, so these are the initial arrangement of orbitals, and Px, Py and Pz, all of them are perpendicular with each other. That means they have 90-degree angle. So hydrogen contains only one s orbital. That means if we draw axis for hydrogen as well, then it has only one s orbital like this. So only 1s orbitals of hydrogen will try to combine with 4 different orbitals of carbon. That means one will try to combine here, second will try to combine here, third may try to combine here. So these are the atoms of hydrogen or orbitals of hydrogen. So all of them right now contains 90-degree angle with each other because they are combined with px, py, pz orbital of carbon, which is 90-degree angle from each other. But fourth orbital will try to combine with s orbital of carbon here. Okay, so that means it will be present here. And if you try to attach fourth orbital of hydrogen with carbon, then they have to repel each other because similar charges repels each other. And because of the repulsion, all of these orbitals of carbon will rearrange themselves to minimize the repulsion. And we know that when 4 orbitals or 4 pair of electrons repels each other, to minimize the repulsion, what is the requirement of shape? It is tetrahedral. Okay, so the 2s orbital of carbon and 1s orbital of hydrogen are spherically symmetrical and they can overlap in any direction. Therefore, the direction of fourth CH bond cannot be ascertained. This description does not fit with the tetrahedral HCH bond angle 109.5. Clearly, it follows that simple atomic orbital overlap does not account for the directional characteristics of bond in CH4. That means they must rearrange themselves, or there will be some other factors as well. If they are directly overlapped with each other, then shape of CH4 molecule should be triangular pyramidal, because we have 3 different orbitals and 3 different elements combined with each other. Just like ammonia, it will show us pyramidal shape. Using similar procedure and arguments, it can be seen that case of NH3H2O molecules, the HNH and HOH bond angle should be 90-degree as well. But it is not, we know that. This is in disagreement with the actual bond angles of 107 and 104.5 in NH3 and H2O molecule respectively. That means something different is also happening in this case as well. And we will discuss about that point in next lecture. Hope you find this lecture helpful, and if you find any difficulty, feel free to ask.